Moving to the various application of operation amplifier, the very first application we are discussing over here is inverting amplifier. So this is the circuit diagram of inverting amplifier. It is a as it is an amplifier means it is having a fixed gain. See here why it is inverting, because you can see that it has got two input terminal. One is the minus and other one is the plus. The minus terminal is you are applying the input. The minus terminal is called as the inverting input terminal, and the plus terminal, that is called as the non-inverting input terminal. See here, non-inverting input terminal is grounded and inverting input terminal we are applying our input. So it is called an inverting amplifier. So output will be only one input here. So V1 multiplied by the gain of the amplifier. Now we will see how we can derive the equation for gain of the amplifier. So this is the same diagram of your inverting amplifier. Now see the non-inverting input terminal. This is the non-inverting terminal. It is connected to the ground. So the voltage at this point should be equal to 0. Now, by virtual ground concept, in op-amp, the virtual ground concept, this terminal voltage is connected to 0. That means the voltage at this point also should be equal to 0. So, this voltage, this is at a potential 0. Now, if this voltage is 0, the current in this loop, that means current through R1, that is equal to, say I am noted it as I1, so V1 minus this voltage, that is 0, that is a potential difference divided by the resistance. So I can write here as I1 is equal to V1 divided by R1. Now see here, this is your output voltage, and output voltage is now and the current through this resistance. There is a feedback resistance connected from output back to input. So the current through this one is given as, so current through this resistor is given as IF. So IF means the output current voltage divide minus this voltage, the current in this loop divided by RF. So I can write here as IF is equal to V out divided by RF. Now the so you in this branch your current is I1 and in this branch the current is IF. Now see what is the current in this branch. So because when I am considering here the node, you have three branches meeting, 1, 2 and the 3. Three branches are meeting over here. So now current at this branch, see here the current is entering, There is a current, no current, as this voltage is 0, no current can flow out from here. So, and it is towards the negative terminal. So that current towards the inverting amplifier, I can write it as, so if a current is there in this branch, I can write it as 0. So the KCL at this loop, current Kirchhoff's current law I can write here as The current entering to the loop is I1. Again, the current entering to that particular loop is IF. The current leaving the loop is I, that is equal to 0. Or I1 I can write it as minus IF. And now we know what is I1 and what is IF. I1 is nothing but V1 divided by R1. IF is nothing but V out divided by RF. And this is minus. So over here, this is the output voltage, this is the input voltage. Readjust the equation, I can write it as V out divided by V1 should be equal to minus RF by R1. This is what is called as the output voltage divided by input. Here the gain is called as the gain, or I can write it as V out is equal to minus RF by R1 into V1, and this is what is called as the gain of the amplifier. Output is equal to gain multiplied by input, and the minus sign because it is an inverting amplifier. So the gain of the amplifier is getting as RF divided by R1. So this is the way we are deriving the gain of the equation. So that's about inverting amplifier. And here there is a small example problem. So here R1 is given, RF is given. What is the output voltage for an input? 2 volt. So you know the equation. It's an inverting amplifier. RF is there, R1 is there, V1 is there. Just substitute the values, get the output voltage as minus 10 volt. So this is the same experiment you have done in the lab as a part of second experiment. This is the same circuit you have done.